Hello students, welcome to 6th lecture of T&F block elements. So in previous lecture we discussed about the silver and its compound and their properties. So now let's start with our next example. So just like silver, we are going to discuss about one more noble metal, gold. So gold is mainly found in native state either as a vein gold, placer gold or alluvial gold. It is also present to a small extent in combined state as sulfide, telluride and arsenosulfide. So that means different compound form of gold. It is considered to be a king of metal because of rarity, because of certain properties and noble characteristics. It is considered noble. Some important ores of golds are calaverite, sylvanite and bismuth azurite. Now let's talk about the extraction. So first process, MacArthur's forest cyanide process. Just like silver, same process will be repeated here, but specifically for silver generally we will use NaCN, but for gold we will use KCN because they give comparatively rapid process. But we can use vice versa for both of them and still we can extract metals. So main thing is, first we are going to make soluble compound of our metals. As we can see here, initially we have our impure metal which has a different type of impurities with it. So we are going to make its compound formation. As we can see, AuCN2 minus. So this compound of our solution or main metal is water soluble. That means now this can dissolve, but our remaining impurities can't. So that means simply by filtering the solution we can get rid of impurity. Now reverse reaction, that means reaction with more reactive metal can reduce our metal. So when we have this compound and when it reacts with more reactive metal like zinc, it can be reduced again. So instead of gold, zinc will get complex formation. That means zinc will oxidize and that means our gold will reduce. And now again metallic gold, that means atomic gold, it is not soluble and that's why it can separate out from the solution. So by simple again filtering we can get rid of remaining impurities and we can get our solid state compound of gold. So this method is first make it soluble and then make it insoluble. So in first step we can get rid of certain impurities which are not soluble and that's why we can get purified compound of our metal. And then we have to obtain the metal from the compound form. That's why we will carry out reduction process which gives us metallic gold which is insoluble. So as mentioned, the powdered gold ore after the concentration by full flotation process is roasted to remove easily oxidizable impurities of tellurium, arsenic and sulfur. The roasted ore is then treated with the dilute solution of KCN in presence of atmospheric oxygen when gold dissolved due to the formation of orocyanide complex. So yeah, as we can see, first we have solution form of our gold, then we can obtain it again back in solid form. Now next, platinum chloride process. The roasted ore is moist with the water and placed in a wooden vats with false perforated bottoms. It is saturated with the current of chlorine. Gold chloride thus formed is leached with the water and the solution is treated with the reducing agents such as FeSO4 and H2S to precipitate gold. So first AuCl3 is formed, then it will react with FeSO4 in which Fe being more reactive will get oxidized and gold will be reduced. So you will get Au in solid form, FeCl3 and Fe2SO4 thrice. That means we have ferric chloride and ferric sulfide. Now AuCl3 with H2S, it gives 6HCl, 3S and 2 moles of Au. Again it will behave as reducing agent for our gold compound. So the impure gold thus obtained contains impurities of silver and copper. The removal of silver and copper from the gold is called parting. This is done by the heating impure gold with con H2SO4 or HNO3 when Ag and Cu dissolves, leaving behind the gold. So copper with H2SO4 gives CuSO4, SO2 and H2O. So it is the reaction mentioned in section of copper. Similarly, silver with H2SO4 gives Ag2SO4 and SO2 and H2O. So same type of reactions will be obtained from silver and copper. Now keep in mind both of them are quite non-reactive metal, but if we compare them with each other, then you will notice copper is more reactive than both of them. On second number in case of reactivity we have silver, and gold will be least reactive in all of these three. So in normal condition copper do not react, but because of presence of other non-reactive metal, first copper will participate in the reactions. Then if we compare the gold and silver, then gold is more noble. That's why silver will participate in reactions before gold. Now properties of gold. So we are familiar with the looks of gold. So as mentioned, gold is yellow, soft and heavy metal. Now ornamental gold is not actually gold, it is alloy of gold. Pure gold is a soft metal. So suppose we have ornaments of gold in pure state, that means pure gold without copper, then it will break or bend easily. That's why to increase the strength we have to make alloy. So your ornaments are not pure gold, but they are alloy of gold. So gold is yellow, soft and heavy metal. Gold and silver are called noble metals since they are not attacked by atmospheric oxygen. However, silver get tarnished when exposed to air containing trace of H2S. Gold is malleable, ductile and good conductor of heat and electricity. But because of priciness, we cannot use it to conductor. Pure gold is soft. It is alloyed with silver and copper to make in the making of jewelry. Purity of gold is expressed in term of carats. Pure gold is 24 carats. Gold 14 carats means that it is the alloy of gold which contains 14 part by weight of pure gold and 10 part of copper per 24 parts of weight. So total number of carats will be 24. If we have 24 carat gold, that means it 100% gold. And as mentioned, if you have 14 carat gold, then out of 24 we have 14 parts of gold and remaining part of other metals like silver or copper. So that means percentage calculation will be for 14 karat gold we have total 100% and 100% is equal to 24. So 14 is equal to how many? So 100 divided by 24 multiply by 14, which is 58.3% purity. So 58.3% gold and remaining will be silver or other metal. Usually our ornaments are made of 22 carats gold for comparatively high purity ornaments, and rose gold like gold contains 18 karat gold. So 22 karat gold, which is 91.66% pure, has iconic color which is known as golden color, so which we observe the color of ornaments. So gold is quite inert, it does not react with oxygen, water and acids but dissolve in aqua regia. So HCl with HNO3 gives NOCl plus H2O and 2Cl into 3 times. So Au plus 3Cl gives AuCl3 2 times. That means we need 3 moles of NOCl. That's why we have to repeat the reaction 3 times, or we have to use 3 times concentrations. And second reaction we need 2 moles of AuCl3. That means we need to use double concentrations mentioned here. So overall reaction Au plus 9HCl plus 3HNO3 gives AuCl3, 2 moles, 6H2 and 3 NOCl. Now oxidation state of gold. The principal oxidation state of gold are +1 and +3, though +1 state is more stable than +3, because in +3 state we can say that it represents higher reactivity, and normally gold is noble metal. Now compounds of gold. Auric chloride. Keep in mind gold is also called aurum and symbol Au. came from the name aurum. That's why in certain case you will notice gold instead of gold aurum word is being used, as we can see here. AuCl is called auric chloride. So AuCl3, it is prepared by passing dry Cl2 over the finely divided gold powder at 573 Kelvin, which gives us Au plus Cl2 to AuCl3. It is red colored crystalline solid soluble in water and decomposes on heating, gives gold 1 chloride and Cl2. So AuCl3 on heating gives AuCl and Cl2. It is dissolved in con HCl forming chloroauric acid, which is the complex compound of gold. AuCl with HCl gives HAuCl4. Chloric acid is used in photography for toning silver prints and as antidote for snake poisoning. Next, orous sulfide. It is prepared when H2S is passed through the acidified solution of potassium orocyanide KAuCN2 and it forms Au2S as mentioned below. It is dark brown solid not attached by the dilute mineral acids and hence is probably the most stable gold compound. So in next lecture we are going to discuss about the zinc and its compound.